All right, one of the things I want you guys to think about, what element is required for us in order to breathe? Oxygen. And that's in what form?
Gas.
Definitely gas. Well, what form? O2. All right, so O2 is the gas we need in order to breathe. Ozone is O3. And single oxygen is known as monoxide, which is a bad thing. CO, which is carbon monoxide, is that something comes out of the car. And if you lock yourself in the garage and run your car for a while, you will not wake up again. Okay? So that is carbon monoxide. So when we think about the air that we need to breathe, that's O2. But oddly enough, all of our life on Earth requires oxygen, at least in some form or another. It requires oxygen and carbon. But what's interesting is the majority of our atmosphere is actually nitrogen. So nitrogen gas represents over 78% of our atmosphere. Oxygen represents the other 20%, leaving us with 1% of all the remaining material in our atmosphere. Think about our entire atmosphere. Oxygen and nitrogen, with nitrogen being 30, basically 3/4 of the entire atmosphere. Oxygen makes up the rest of it. Then we have these tiny little floaters. Okay? Here's what's amazing out of this. Want to talk global warming for a minute?
Sure. Yes.
Carbon dioxide, that horrible greenhouse gas. Horrible. Do you guys see what percentage it is of the entire atmosphere? It's 0.03% of the entire atmosphere. Pretty much. I don't understand how something that represents less than that would be what, 3/10,000ths of the entire substance would have that much of an influence. I mean, seriously, if you had that much cyanide, you would not even notice you had cyanide in your system. Just think about percentages, starting in. Water vapor, on the other hand, varies from 0 to 4%. Why does that vary? Yeah, there's not much water, right? Well, not that, but remember, it's a constant cycle, right? The water cycle is a constant cycle. So while we have some evaporating, it's also precipitating. That does not mean that there's an equal amount of evaporation as there is an equal amount of precipitation. They are not balanced, but it is always a complete cycle. So there might be periods of time where we're having higher evaporation rates than usual with low precipitation rates, so we'd have an increase in our water vapor. Now, if you add all this up, you'll notice that we're off by 0.01%. Well, that's all the other junk that's up there. Including the ozone, helium, hydrogen, methane, which is another evil greenhouse gas, methane, which is naturally released by the earth, I say. Humans are the source of all evil on this planet. It can't be the earth. Why would the earth destroy itself? Because it does that. Krypton is also up there. Yes, krypton is actually an element. We actually have ozone, xenon, and neon. So a lot of our halogens are up there. Now, your hydrogen and helium, at what level do you think you're going to find those? Where? I would say basically your upper thermosphere to right about the middle of your exosphere. They are the lightest elements, therefore, think about densities. The denser you are, the closer to the center you are. So your helium and hydrogen are quite a ways out there. Okay? They're really light, so they're on the very far outer edges of our atmosphere. As you get heavier, we get closer to the ground, which is why we find oxygen, which is very heavy, closer to the ground. So we have carbon dioxide. It's a very heavy gas, and therefore it hangs around close to the surface. Why? It's a big bus on It's amazing. When you hear the arguments for global warming, scratch that, for mandating global warming, it sounds reasonable. You start looking at the numbers. You start looking at the paleoclimatology. Paleo means old, climatology is the study. So climate, so we look at the study of climates over the past billion years or so, which is locked up into our ice cores at the poles. It doesn't match up. Of course we're warming. The Earth does that. It warms and it freezes. It warms and it freezes. It doesn't. Guess what the climate was like before the last ice age? It was tropical, to the point where we had dinosaurs in Alaska. Last I knew, humans weren't around then. Don't think we could have created a whole other global warming. It does that. It's a natural cycle. Sometimes it happens very fast, which is why we have mass extinction with climate change. Because some species can't adapt fast enough, therefore they go extinct. Just the way it is. Just the way it is. Alright. So, main concept out of this page is make sure that you understand that nitrogen, boom, represents the majority of our atmosphere. Oxygen represents the other majority. And then you have this tiny little sliver that represents everything else in the atmosphere. So, with that in mind, we've already talked about water. And we're going to say, okay, 0 to 4% doesn't really sound like a lot, but in fact, the very essence of water is what allows our planet to be a nice, loving home to us. If we didn't have, my God, seriously, close the shades. Last night, so they lose something shiny out the window. Okay, so when we look at water, it's the role of the oceans to take that heat from the equator and disperse it to the poles. And if that didn't do that, you would not be able to live here in Indiana. It would be way too cold. You certainly would not be able to live in Northern Europe. Yeah. Because it's very nice. Actually, they have a climate very similar to here. And it's all because of the way that the oceans disperse that heat.
Because we also have so much water.
So without water, the transfer of heat energy would be almost impossible on our planet. So that's just something I want you guys to understand, that basically we have that. Now, here are some other key things to remember. Water actually helps regulate the energy that's absorbed within the atmosphere. Remember, water has a huge, huge ability to store a tremendous amount of heat. It'll regularly absorb that heat and store it for a very long time. Carbon dioxide, on the other hand, does actually prevent the release of long-wave radiation, which is why carbon dioxide near Earth's surface is a really bad thing. I will agree with the environmentalists on that one. It's not great to have a lot of carbon dioxide near the surface. One of the other things to keep in mind with water, so like I said, it helps regulate our atmospheric heat. But also without water vapor, we would not be able to get clouds, which then form larger systems, and therefore precipitate and give us rain and snow. Without that weather, without water, we would have no weather. And the last one is that heat is either absorbed or released every single time we have a phase change. When we go from water vapor to liquid, so going from water vapor to condensation, we have a release of energy, release of heat. When we go from liquid to the gas, we actually have an absorption of heat. Now, what other things do we have in our atmosphere? Talk about a bunch of gases that are up there. What else is up there? Such as. What else is floating around in the sky?
Clouds.
Clouds is water vapor. Well, what else? Dust. Good. What else?
At night you can see stars.
Well, stars are accepted in our atmosphere. What do you mean? Yeah. Okay, so we have dust already. We talked about. We have charged particles in our atmosphere. Now we're talking about those in the magnetosphere. Yeah, that's the charged particles. What else is in our atmosphere? Do we exist in our atmosphere?
More technically.
So where does the troposphere start? How far off the ground?
Oh wait, no, it's stabilized.
What? No. Where does it start? Actually starts right at ground level. So from 0 to about 7 miles high is the troposphere. So the fact that we actually exist in our atmosphere, we have planes that travel through our atmosphere. Some of our satellites are in orbit in our atmosphere. So we have a lot of different stuff that's flying around in our atmosphere. We have meteors that come in through our atmosphere. Thank goodness we have a strong atmosphere that helps us be protected from falling rocks and falling debris. Unfortunately for our astronauts, sometimes that doesn't work out too well for them. We often will have some tragedies that go along with that, which is very unfortunate. So those are some things to think about. So when we talk about our atmosphere, we understand we have 5 layers, right? This is what you guys were supposed to do the first half of this class. We're supposed to look at 5 different layers. So the first layer we're talking about is the troposphere. The important thing about the troposphere, so if you look at this diagram, the troposphere is just this very tiny sliver of the overall expanse that is our atmosphere. Okay. Think of it like this. Why is it so squished downward?
Because it has all the atmosphere.
Yeah, all the other atmosphere is sitting on top, squishing down, condensing it. Here's what's interesting. We'll see this information here in the troposphere.
Well, that's what, isn't that what it has kind of life sustainable?
Yes.
Can you scroll up a little bit? Just to see
Guys, when we look at the troposphere, it is the... Whoa. Let's try that again. It is the closest to the Earth. It goes basically from about 0 to 10. Some of you guys got varying numbers. Again, all you need to know is that it's not like 40 kilometers off the ground, but about anywhere from 0 to 10. And it's not like this clear-cut, flat line that goes all the way around the globe. It does actually kind of undulate a little bit. So some places are thicker than others. The way the air flow. So the other thing to keep in mind is that tiny sliver represents 80% of all the material in our atmosphere. You guys get that? Keep that in mind. Okay, this is really, really important. This tiny little sliver, the first 10 kilometers of our atmosphere, contains 80% of all the atmosphere. That means all the rest of this is only 20% of our atmosphere.
Yet it's still heavy enough.
That's why. All that weight is pushing all that material down to the ground. Remember, gravity and density are the driving principles in our atmosphere. The gravitational pull of the Earth, using the density of the materials in our atmosphere, pulls all that down close to the surface. So 80% of our material is actually located in our troposphere.